Hi, Psych41. I just wanted to go through the notes from the factorial design that we didn't get to, in case it doesn't make sense from the notes that you've got or from what you can read in the book. So we were talking about factorial designs. These are experiments when we have added an additional predictor variable. All that factorial design means is that there is more than one predictor variable. And so we're using the word factor here as a synonym for the word cause or a synonym for the word predictor variable. It's a source of systematic variance. It's a source of non-random variance. And we use this example of we might have two different factors, whether you're on the cell phone, yes, no, and then what your age is, whether you're younger or older, and end up with 4 different cells. So let's go through an example. If we wanted to ask, does teacher's response, which is going to be our independent variable, have a significant effect on the pupil's subsequent effort on their next test? So their subsequent effort is going to be the dependent variable. So we're going to train our teachers in 3 different response types. We might train them to be to give criticism to the student of, maybe quite sternly saying, I don't think you tried as hard as you could have, or, I think you could do better. I expect more out of you. We could train them to respond to some students quite neutrally. I'm sure you did your best, or, here's your grade. Are you happy with it? And we could train them to praise the student and really, say, I'm very proud of you and you did a great job on this test. So that's going to be the independent variable, where we'll have each teacher assigned to give different levels of that criticism or neutral or praise response to different pupils. And then we're going to measure the pupil's effort on the next test. So let's say we did that and that this is what we found. And we would look at these and say, wow, the criticism, the neutral, the praise groups, they're all really about the same on effort on the next test. Wow, there's no significant effect of teacher's response. That's surprising, because it would seem that having these different responses might make you perform differently. But that would be the results of that first experiment. So often when we run experiments and we get results that we're not expecting, we go back in to look at the data and really query, is there something else going on here? And it's like a treasure hunt, where we're looking through our data to see if we can see the pattern, see if we can see, is there a different pattern going on here? And so in this case, we've just got a little bit of the data where we've got 4 of the students who had critical responses and 4 of the students who had neutral responses and 4 of the students who were praised, and then their effort and the average effort for this group. And so we might look at this and say, okay, the average was 2.4 in this group, but wow, there was a lot of variability with a lot of people down, giving very little effort and a couple of people giving a lot of effort. And then we might look at this group and say, okay, the average was 2.1, and oh, yeah, pretty much everyone's right around the average there. There's not much other variability going on. And then we might look at this group and go, okay, the average is 2.6, and boy, again, it looks like there's another factor. It looks like there's something else going on here. If only we could sort out the group that's performing low from the group that's performing high under the praise conditions. So do you see what I've got here? I've given you their names, and that should give you some indication of their gender. And there's another variable going on, where if we take the boys who were criticized and look at their mean performance, and the girls who were criticized and look at their mean performance, and then the girls who were praised and their mean performance, and the boys who were praised and their mean performance, then we see that a completely different pattern emerges from the data. So we run these because many factors contribute to our behavior. We conduct factorial experiments and we analyze multiple predictor variables because they allow us to investigate the effects of more than one predictor variable. It makes it more like real life because there are many variables that contribute to our behavior. And sometimes, like in that example, if we only looked at teacher's response, we missed the effect completely. It was obscured. So we had to look at, within those different genders, how did the teacher response influence the children's subsequent effort? And so sometimes the effect is contingent upon the presence of several variables. So in this case, we've got two predictor variables. We're going to call them variable A, teacher's response. It had 3 levels. Variable B, the gender of the pupil, that had 2 levels. The outcome variable was the dependent variable, is the effort on the next test. So we end up with what we call a 2 by 3 factorial design. We read the word X there as the word, or the letter X as the word by. So we say a 2 by 3 factorial design. The number 2 refers to one of the predictor variables had 2 levels. The number 3 refers to the other predictor variable had 3 levels. So by knowing that it's a 2 by 3 design, we know that there are 2 predictor variables because we've got 2 numerals there, and one has 2 levels and one has 3 levels. So we could lay it out and think about, there must be 6 different cells here. The females who were criticized, the females with neutral, blah, 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 blah. You know that. And then we're going to look within those at the mean of each group. So when we're analyzing a factorial design, we need to consider both the main effects of each predictor variable. So each predictor variable may have an effect just by itself. And we also then ask, do the variables interact? And the answer here is either yes, they interact, there is an interaction, or no, it's just additive. Let's look at the main effects. So if we wanted to look at the main effect of factor A, that was teacher's response. So we're just asking the question, does teacher's response have a significant effect on subsequent effort? So we're going to compare the overall means. We're going to collapse over the level of gender. We're going to ignore the gender and just look at all of the children who receive criticism, all who receive neutral, and all who receive praise. And so we're collapsing the data over the other factor. We're ignoring that other factor. And so here's our cells. We're ignoring whether they're male or female, and we're just looking at, of all of the students who were criticized, here's the mean, neutral, and praise. Those are the means. That's where we started, right? That was a simple experiment, the main effect of teacher's response. Now let's consider the main effect of the other predictor variable. Does gender have a significant effect on subsequent effort? So we're going to compare the overall mean for the girls versus the boys. We're going to ignore the other factor. We're going to collapse the data over the other factor. So we're going to take our data and we're going to average just, do girls or boys give different amount of effort or the same amount of effort, ignoring whether they'd been criticized or treated neutrally or praised. And so when you do this on your homework, you will just be averaging those averages, or averaging all of the level 1 and all of the level 2 of that predictor variable. And I think on your homework, I've given you a rule of thumb. Like if it's more than 1 point different, then say that yes, there is a difference there. We'll get into the actual decision rule next week when we start talking about statistics. And so here is our outcome for the comparing just the genders, and we can see and say, no, there's no difference. The gender of the pupil does not predict the amount of effort they give on the test. So now let's look at the interaction and ask, is there an A by B interaction? Is there an interaction between these two variables? Did the teacher's response have a different effect depending on gender? That would be an interaction. Or was the effect the same at each level? And that would be an additive effect. And so we're going to compare all 6 groups. So we're going to come back and look at each of those means. It's easiest to do this visually. It's really a good idea to visualize the data at this point and to sketch out a graph. We're going to practice that next week. So here we've got the levels of the teacher's response, criticism, neutral, praise, and the girls and the boys. And we're going to look at that and say, when the girls are criticized, here's how they're performing. When the boys are criticized, here's how they're performing. When the girls are praised, here's how they're performing. When the boys are praised, here's how they're performing. And so we look at this and we ask a couple of questions. We ask, first off, do these lines look roughly parallel? And you should be looking at those and saying, no, they don't look at all parallel. They look as if they are actually going in absolutely opposite directions. So we would look at that and conclude that there is likely to be an interaction. Before we go on to the conclusion, let's have a quick note about notation. As I said, we say 2 by 3 factorial design. There are 6 cells. The number of numbers, the number of numerals, indicates how many predictor variables there are. In this case, there are 2. And then the values are how many levels. One has 2 levels, one has 3 levels. So we say a 2 by 3 with 6 cells. Go ahead and practice these. So if we had gender, male, female, by age, child, adult, what would that be? Are you waiting for me to tell you? Okay, it would be a 2 by 2. So how many main effects could there be? There's one main effect for each predictor variable. And we've got 2 predictor variables, so there'd be 2 main effects. Don't be confused about the levels of the variable. That's a fallacy or an error that some intro research method students make, where they don't keep their variable labels and their variable levels straight. And so they might say, oh, there are 4 cells in this case. There could be 4 main effects. And that's not true. There's a 1 main effect for each predictor variable. So there could be 2 main effects in this situation. How about if it was gender measured male, female, by age measured child, adult, by treatment group, group 1, group 2, group 3? What would you call that? A 2 by 2 by 3, right? And how many main effects could there be? How many predictor variables are there? Are you getting the picture here? So there'd be 3 predictor variables there, so there could be 3 main effects. I'll just put up the other ones. So there's another one for you to practice. A 2 by 3 by 3, right? With 3 main effects, possible. So when we consider the main effects, we're looking at just the overall effect of one of the predictor variables. So we're collapsing the data over the level of the other variables. And the word effect there is meaning the change in the outcome. Did it change the outcome? Did it change the dependent variable? So in this case, we could look at the main effect of teacher response, criticism, neutral praise, the average is there, and then the main effect of gender, male and female, the average is there. Then we start looking at whether it's an additive effect or an interaction effect. Additive effects, the effects of the 2 predictor variables add or subtract together in a linear trend. So the effect doesn't depend on the level of the other predictor variable. And the rule of thumb we're using at the moment is that the graph will look roughly parallel. And we'll use that rule of thumb until we get to the inferential statistics towards the end of the term. Here's the example that we went over quickly in class, where we said if our factor of interest was physical state and our outcome was school situation, and then our outcome was well-being, that your physical state might influence your feelings of well-being by itself, have a single factor effect, have a main effect by itself. And that if we add in a second factor of you got an A on a midterm, we can see that that increased your well-being regardless of physical state by almost exactly the same amount, that your well-being improved a little bit regardless of your physical state. And so we could say that your well-being was your physical state plus your midterm grade, that's a linear adding together. And we might interpret that using this sentence. Earning an A on a midterm improves well-being regardless of physical state. That word regardless of is telling you that it's an additive effect. An interaction, the effect of one predictor variable differs depending on the level of the other predictor variable. And so these graphs will not look parallel. So if the midterm is you've got your well-being just based on your physical state, and then if you arrive at school and find that a midterm is postponed, if you were well rested, your feelings of well-being would probably decrease. You'd probably be quite frustrated that the midterm was postponed. If you needed sleep and your midterm was postponed, okay, that's pretty good. That makes you feel a little bit better. if you had the flu and you dragged yourself in for a midterm and you were really worried that you weren't going to do well because you've got the flu and you find out that it's postponed, you probably are going to be very much feeling better, and your feelings of well-being will increase significantly. And so we look at this, the effect of your midterm being postponed has a different effect depending on the level of physical state. So it might have a negative effect, or a small positive effect, or a huge positive effect. It all depends on what your current physical state was. And so those are those effects. And we might use a sentence like this. There is an interaction. A postponed midterm can have a positive or negative effect on well-being depending on the level of physical state. So the effect of one variable, postponed midterm, differs depending on the level of physical state. So that's all the information that I wanted you to have about factors and interpreting factorial designs.